Hello, today we're looking at the cross product. Okay, so let's have a look at the cross product and what we're asked to do today. We're asked to calculate the cross product for the following pairs of vectors. All right, so we got a couple of pairs of vectors here. And then finally, okay, so we'll leave the second question till later, but definitely for part A and B, it's a direct calculation problem. All right, so how do we calculate this cross product? How do we do this? Well, let's scroll over here. I've actually written out a method or formula for finding out the cross product. So we're given two vectors A and B in R3. So we can only find the cross product of vectors in R3. And we have general vectors. So our vector A is A1, A2, A3. Vector B is coordinates B1, B2, and B3. And then we put them into this box. So later on, you'll learn that this box is actually a matrix, and these vertical lines actually telling us to find the determinant of the matrix. But for now, we'll just think of it as a box of numbers. It's more than just a box of numbers, because the I, J, and K, these actually represent, so it's actually not, in this case, a box of numbers, box of symbols. Second two lines, last two lines are numbers, the coordinates of our vectors A and B. The first row, the I, J, and K actually represent our unit vectors for R3. But for now, we just leave them I, J, and K. So once we have this box of numbers, this is what our cross product looks like in the end. So it's a vector, and that's determined by the I, J, and K. And the coefficients of the vector or the coordinates of the final vector are given by these values here. Okay, and we can determine them from our box. So if you notice for I, we have A2 times B3 minus B2 times A3. So we're actually looking at this little box right here. For J, the coefficient of this vector is A1 times, it's actually A1 times B2 minus B1 times A, sorry, where are we? A1 times B3, my mistake. Get a little confused here. Oh, that looks right. Yes, A1 times B3 times B1 times A3. So let's use a different color for that. That purple. A1 times B3, B1 times A3. That's what we have here. And then finally, the coefficient of K is A1 times B2 minus B1 times A3. So we'll use yet another color. And we're dealing with this yellow box right here. All right. Okay, so now let's apply this formula to our example. So calculate the cross product for the following pairs of vectors. So in part A, we have vectors 5, 1, 2, and 2, negative 4, 3. So let's make, Susan, our box. So let's create this box, I, J, K. We'll put our first vector in, 5, 1, 2. Our second vector in, 2, negative 4, 3. And we're going to start evaluating. So our first vector I and its coefficient, we need to consider this first box of numbers. So we have 1 times 3 is 3, minus negative 4 times 2, which is negative 8, plus 8, minus J times coefficient of J is now 5 times 3, 15, minus 2 times 2, which is 4, plus K times the coefficient of K is this second box here. So 5 times negative 4 is negative 20, minus 2 times 1, which is 2. Let's simplify. So we have I times 3 plus 8 is 11, minus j times 15 minus 4 is 11. Oh, that's interesting. Plus k times negative 20 minus 2 is negative 22. Let's clean this up. So we have 11i minus 11j minus 22k, or in coordinate form, we have negative 11 and negative 22. Good. All right, let's try this again. We've got 2 more pairs of vectors. Again, we want to find the cross product. So what do? We create this box. ijk in the top row, 3, 1, 2 in the second row, 9, 3, 6 in the third row. Put our vertical bars on either side. Let's start. So I, coefficient of I, first box. So 1 times 6, 6, minus 3 times 2 is also 6. Interesting. Minus j times 3 times 6, 18, minus 9 times 2, again 18. Very interesting. Plus k times, coefficient is from this third box, so 3 times 3, 9. 9 times 1, 9. Again, very interesting. So let's evaluate. We get 0i minus 0j plus 0k, or 0, 0, 0. We get the 0 vector. Interesting. So let's have a look at these 2 vectors. So if you notice the 2 vectors that we started with, they're actually multiples of each other. So the second vector is actually 3 times the first. That means these 2 vectors are actually pointing in the same direction. Why don't we give them names A and B? So we have vector A and vector B, which is just a multiple of vector A. When you take the cross product of 2 vectors pointing in the same direction, we end up with the 0 vector, which is exactly what we calculated. Okay. We can actually generalize this statement. Why don't we generalize it as follows? Again, this is not a proof of it, just an example. So if we have A and B equals k times A, where k is some kind of scalar, some real number, then what are we given? Vector A and vector B, where vector B is a multiple of vector A and k is some real number, then A, cross product of A and B, is actually the 0 vector. All right, good. All right, second question. So we're given vectors A, B, C, and D, and we're asked, without doing any calculations, explain why we have this expression here. Okay, we have A cross C cross B cross D equals 0. All right. Let's have a look at all these vectors. Well, A cross C, what do we end up if we do A cross C? Why don't we just do it? Let's see what happens. It's probably the best way to do it. Whoops, A cross C. I, J, K. A is 3, 0, 0. C is 3, negative 1, 0. Let's call this A cross C. Let's calculate this. So we have I. We'll start with I. The coefficient of I is 0 minus 0. Okay. Coefficient of J is 0, 0 again. Okay, and plus K, coefficient of K is, oh, look at that, negative 3. What's up, Todd? Negative 3K. All right, so now let's do the second one. Cross product, let's see if we have room of B and D. So now they tell us not to do calculations, but sometimes, you know, if you have to do them, you have to do them. All right, so B, 0, negative 1, 0, D, 4, 3, 0. Okay, so for I, so I, coefficient of I is again 0 minus j. Coefficient of j is, that's interesting, it's, let's see, 0 minus -4, which is +4, plus k times the coefficient of k is, oh, hang on, I think I made a mistake there. Oh, math is full of mistakes, but if you can catch your mistakes, it's okay. So j, so the coefficient of j is actually 0, plus coefficient of k is 0 minus -4, which is 4. Okay. Okay. So if we look at the cross product of A cross C and B cross D, we notice that we're crossing two vectors that are actually parallel because they're pointing in the same direction. So K is our unit vector in the direction of the Z-axis or in the Z direction. And so what do we know about the cross product of two vectors that are multiples? It actually equals a 0 vector. So we should put a vector sign over there. All right. So if we want to explain this without doing calculations, if we look at the vectors A and C, we notice that they're both in, so let's have a look at our vectors a bit closely. So we've done calculations, and while they told us not to do calculations, sometimes calculations help us see what's going on. So now if we go back to our problem, we see that A and all our vectors, A, B, C, and D, all lie in the xy plane. So that means when you take the cross product of any two of these vectors, A, B, C, or D, we're going to get a vector perpendicular to the given two vectors. So that's going to be a vector in the Z direction. So the cross product of AC is going to be some multiple of the vector K. So let's draw that out if it's easier to see. Okay. So we have our axes, Z, X, and Y. All our vectors, let's use a different color, A, B, C, and D, they all lie in this XY plane. Where exactly, I don't know, but that's okay. They all lie in this plane. So that means their cross product is going to be perpendicular or some multiple of our unit vector K, which is in the Z direction. This means we're going to have the cross product of two vectors that are parallel to each other. And when we take the cross product of two vectors that are parallel, we're going to end up with a 0 vector. All right. Okay, so that brings us to the end of our session today. If you have any questions, please send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching, and we look forward to seeing you soon.